Hello guys, this is Ishan Akbar with a new video about the calculation of steel in a concrete slab or in a RCC slab. This video is specially made for civil engineers who are working in design of concrete structures. For this, I have taken example of a slab. Let us say we have a slab whose dimensions are basically length and width, which are required for the calculation of steel. So let us say this is the width of the slab, and along this axis this is the length of the slab. You just need to note down the length and width of the slab. In this case, let us length is 20 feet and width is equal to 10 feet for the slab. So the first thing which you must know to calculate the steel total amount of steel required for the construction of the slab is the diameter of the bars. So here, I will let you know that what the minimum diameter of a bar is required for a slab construction. It is 12 millimeter minimum. And what should be the spacing between the bars? So let us say these are the main reinforcements provided along the width mean length of the bar will be along the width of the slab. This is known as the main reinforcement or main bars. These are known as M bars, and other bars are provided or length of those bars is along the length of the uh, slab. So these are known as the distribution bar, D bars. So what should be the distance or center to center spacing for main and distribution bar? A minimum center to center spacing, this is 6 inches, or you can say this is zero point 0.5 feet or 1 by 2 feet. So these are two basic parameters which you must know while designing the slab. So now we will basically determine the how many number of bars are required in longitudinal direction, how many bars are required along the transverse direction, or you can say that how many bars are required as main bars and how many bars are required as the distribution bars. So for this you must know the length of the slab, which is equal to 20 feet, and width of the slab, which is equal to 10 feet in our case. So what will be the number of main bars? This is equal to simply diameter of the length divided by the center to center spacing plus 1. This one is added due to this gap provided along the concrete and the first reinforcement. So what is the length? That is 20 feet divided by what is center to center spacing? This is zero point 0.5 feet, because this is in feet. So this center to center spacing will also be in feet. So it will be equal to 40 plus 1 equal to 41 numbers. So total bars required in the longitudinal direction are total number of main bars is equal to 41. So in the same way we will calculate the number of distribution bars. This will be width of the slab divided by center to center spacing plus 1. So what is width? That is 10 divided by zero point 0.5 plus 1. That is equal to 10 by zero point 0.5 will be 20, and 20 plus 1 will be equal to 21 numbers. So this is a simple formula to calculate the number of bars required as main and distribution bars for a beam, for a slab in longitudinal and in transverse direction. So when you have got the number of bars, so what will you do? Simply, you will just get the number of bars in directions. The length of bars. So we need 41 number of bars. What will be the length of total 41 bars? So if we say that the length of a bar in a length of a main bar, because the main bar is along the direction of 10 feet, so it will be 10 minus cover of the concrete provided along the. So I will do this like this one: 41 bars into 10 feet minus how much concrete cover is provided. Let us say 1 inch on each side, that this bar will have a clear concrete cover of 1 inch on this side and 1 inch on this side. Then it will be 2 inches divided by 12 to convert this into feet. So when we subtract 0.16 feet from 10, so it will make a larger difference at the end. So it will be 9.83 times 41. It will be 403, or you can say 404 feet, because our dimensions are fit. So total required length for the main bars is 404 feet. And if we are going to calculate length along the length distribution bars, that how much length, total length of the distribution bars is required, that will be 20 minus same, that will be 2 by 12, subtracting the concrete cover, that will be 20 minus 2 by 12 multiply by the 21, it will be equal to 416.5, you can say 417 feet. So the total length of steel bars is equal to length of main bars plus length of distribution bars. So it is 404 plus 417. It will be equal to 821 feet. So we will convert it into meters. So simply you have to divide it by, uh, when you divide feet by 3.28, it will be converted into meters. So 821 divided by 3.28 will give you 250.3, or you can overestimate as 251 meters. It's round about 251, 250.3, so I am overestimating it to 251 meters. So total length of steel is equal to 251 meter. Till now we have not discussed about the diameter of the bar being used as a reinforcement. But in this case, uh, now we will determine the total weight of the steel required for construction of this slab, that may be calculated. So how we can determine the weight of steel? That is equal to d square by 162, and here you will use the value of d in millimeters. This will give you the answer in kg per meter length of the steel. It means that you have to put the value of diameter in millimeters, and it will return you answer in kg per meter, mean how much uh, kilograms or how much weight mass of the steel will be required for 1 unit construction of this slab. So simply we will determine the weight, and I am considering that we are using the minimum diameter of 12 millimeter. So it will be 12 square divided by 162. That is equal to 144 over 162. It will give you 0.88 kg per meter. It means that for 1 meter construction of slab or 1 meter usage of steel with 12 millimeter diameter, you will have to use 0.889. You can say it as 0.889 kg per meter. For 1 meter construction of slab using steel will consume 0.889 kg of steel. But in our case, the total length is 251 meters. So how much total steel weight will be required? Simply we will multiply the weight of 1 meter uh, bar with the total length. So it will be 0.889 kg per meter multiply by 0.889, sorry, 251 meters. Meter will be cancelled with this one, and we will get an answer of 223.11. Let us say this is 224 kgs. So you will need a total steel weighing 224 kilograms for the construction of this slab, whose length is 20 feet, width is 10 feet, and diameter of bars being used along the longitudinal direction and as a main bars is 12 millimeter, and the center to center spacing of both the main and distribution reinforcements is 6 inches. You can try another calculation data, and you can get different answers by assuming different dimensions of the slab, by assuming different diameter of distribution bars and reinforcement bars, and by assuming the different spacing between the longitudinal and transverse reinforcement. So, what will we conclude? That total weight of the steel is 224 224 kilograms for the construction of a slab whose length is 20 feet, whose width is 10 feet, diameter of the bars is 12 millimeter, and center to center spacing between the bars is 6 inches. Simply. And the minimum thickness for the slab in some cases is 4 inches, but 5 inches is preferred to avoid any failure at the end of the structure. Thank you very much. See you in the next video. Take care. Allah Hafiz.